Okay, this is part two. In part two, we're going to use what we just saw about the order of your factors to sketch a polynomial function from factored form. And what I've done is I've outlined 4 steps that we need to take in order to graph. The first step is actually to find the y-intercept. The y-intercept can be found by taking x and setting it equal to 0 because we know at the y-intercept x will be 0. So we're going to start by letting x equal 0 and solving. So what is f at 0? Well, it would be negative times 0 plus 2, 0 minus 1, times 0 minus 3 squared, which would be 2 times negative 1, which is, negative times 2, which is negative 2 times negative 1, which is 2, times negative 3 squared. Negative 3 squared is 9, so 9 times 2 is 18. So that means the point 0, 18 is our y-intercept. And if we go down to our graph, I had to adjust my scale, so you may have to change yours too in order for it to fit. We should have a intercept here at 18. Okay. The second step is to find the roots, or find your x-intercepts. Well, the roots come from your factor brackets or from setting the function equal to 0. So taking the function and making it 0. So f of x is now 0. We got negative x plus 2, x minus 1, and x minus 3. And if we look from each bracket, we can pull out the root. X equals negative 2, because negative 2 would make that bracket 0. X equals 1, because 1 would make that bracket 0. And x equals 3, because 3 would make that bracket 0. So we have 3 roots, which are 3 x-intercepts in this case. So if we go back down to our graph, our 3 roots are negative 2, negative 1, positive 1, and positive 3. And now to sketch, we're going to use these points, and we're going to use what we know about polynomial functions to come up with a sketch. And the way we can do that is, well, we can test behaviors around our x-intercepts to see if the graph is above or below the x-axis on those values. So we know the graph should be passing at negative 2, at 1, and at 3. These are our x-intercepts. So if we test values to the left of negative 2 in our function, we can see whether it's positive or negative. If we test between negative 2 and 1, we can see whether the graph's positive or negative. And if we test between 1 and 3, we can see if the graph's positive or negative. And again, after 3, so a number bigger than 3, we can see whether it's positive or negative. See whether the graph's above or below the axis. And then we can start to piece together. We can also use the behaviors around our zeros. Our first behavior around this 0 is of order 1, so it should behave like a line. It should go through that 0. Our second one is of order 1, so again it should go through that 0. And our third one is of order 2, so it should bounce off that 0 and stay either positive or negative depending what it was to the left of 3. And I'll show you what that looks like. So first let's test a value bigger than negative 2 in our function. So let's test f at negative 3. If you plug that into the function, you get negative 144. So that means we're coming from the negatives as we approach 2. And as we approach 2, since it's order 1, that's 0, we're going to cross right through 2. So our function is going to come up from the bottom, and it's going to cross. It also means that our function is starting from the negative, or as x approaches negative infinity, y is also approaching negative infinity, or f of x is approaching negative infinity. Could we have found that a different way? Well, yes, we could. What's the degree of this function? If we go all the way up to the top, the degree is 1 plus 1 plus 2. If we add the orders, so it's degree 4, and the leading coefficient is negative. And what we know from our previous lessons is when we have a degree 4 with a negative leading coefficient, it means we're opening down, or both end behaviors are pointed down. So that should tell us that we're down here too, on the right side. And if we test the function at 4, a number bigger than 3, we get negative 18, which means we are down. So we know the ends of our function now. And if we test a value between negative 2 and 1, we would expect a positive answer because we're already up. And at 1, we're order 1, so it means we're going to cross the graph like a line here. So we'd expect to get a positive number if we plug in, say, 0, which we would, because we know that f at 0 is 18, because we have the y-intercept. So that means we're up, and then we're going to cross like a line, because it's order 1 at our 0 of 1. We're going to go down. So that means if I plug in a number between 1 and 3, I should get a negative number. And if I plug in 2, I get negative 4, so I am negative. And we're going to go up to 3. 0 at 3 is of order 2, so it's going to behave like a parabola, so it's going to touch and bounce back down. So that's the general shape of our function. Now how do we translate that to a graph? Well, we use the key values that we took from our chart when we tested values, and we plot it by following through the x-intercepts and y-intercepts like we should, respecting the orders of our x-intercepts. So let's use the sketch we just did, our test, to actually draw our graph. We know the function at negative 3 is negative 144, which is way off the graph. So we're coming in from here very steeply through negative 2. Okay. We didn't test 1, so we don't know where it's going through 1, which is okay. You don't need exact points at this point, because we do know that at 18 we're at 0. We don't know whether we peak up here and then go through 0, or if we come up and then peak on the other side and then come back down. And if you wanted to know for sure, you would test negative 1 in the function, get a value, and then you know which side you're coming from. But for how accurate I need your graphs, you do not need to test that value. What I can tell you is that since there's more room to the left than there is the right, we can assume probably that we're going up here and then coming back down. We're off the graph because we don't actually estimate that value. We come back down. We're going to go through our 0 at 1 because it was of order 1. So we're coming back down and we're going through our 0 at 1. 2 is negative 4, so that means we're going to come to about here. Come down, hit that point, and we're going to go back up. And we're going to bounce off because it's order 2. And 4 is negative 18, so that means we're going to respect this point right here and try to hit that as close as possible. And then end down. So here's a sketch of f of x. And that is as accurate as I would need it if you were sketching this polynomial. Okay? Respect the order of the zeros. Make sure you have the y-intercept, and then estimate your terms. And that is a valid sketch of that function. Okay, thanks for watching. One more video, part 3, follows.